Now we want to look at a piecewise-defined function. Keep in mind that piecewise-defined functions are still functions. That means you plug in one value, you only get out one value. Now it may seem kind of confusing because you have three different expressions here for this function. But that's why we have these conditions over here on the right side. And what that means is that if you plug in an x value that's less than -9, you're going to plug it into this expression only. If, on the other hand, the input value is between -9 and 4, including those because of the equal signs, if you have an input value somewhere in here, this is the expression that you get. If you plug in a value of x that's greater than or equal to 6, you plug it into this expression only. So what we have to do, the first part of our job is to take the input value and figure out into which of these three will it fit. And once we know which one it fits, you plug it into the corresponding expression. For example, if we need to evaluate f of -16, keep in mind, you are plugging in one number, you can only get out one number, or else it's not a function. So is -16 going to fit in here, here, or here? Now, sometimes this can be kind of confusing, so I like to do this. I like to draw a number line with these values marked on it. At -9, I see I've got another important thing at 4, and then over here at 6. And then I like to color code things. So I'm going to take this first piece right here, and it says when x is less than -9, so that means not including -9, but going to the left, any number on the number line that's in this region is going to get plugged into the expression 7 minus 5x. Okay? And that's it. And then we have this guy right here. So I'm going to use my darker blue pen for that. And so this says between -9 and 4, including those guys. So I'm going to do brackets on both of these. So any number that falls in this region, we're going to use the expression 45. Okay? And then I'm going to use green for this one right here. So this is green. And this says if you plug in a value that is greater than or equal to 6, then you're going to substitute it into the expression 3/2 times the quantity x plus 3 squared. So when you are given a number, you've got to figure out, does it fall under the pink, the blue, the green, or is it in this no man's land right here where there's no expression for it? So this first one, f of -16. When -16 is right here, and you see that it falls under that pink umbrella, right? So that means I'm going to use this expression to evaluate this. So that means I'm going to say 7 minus 5 times -16, and I'm just going to work it out. I'm not going to plug -16 into these other expressions because -16 is in that pink area, and only that pink area. So doing the math, that's 7, 5 times 16 is 80, and the two negatives multiply to give you a positive. So these guys combine to give you 87. That's all there is. Don't make it more complicated. If I ask you to do f of 9, well, where is 9? Well, 9 is all the way over here, and you see that he falls under this green expression. So to evaluate this, I plug it into that green expression. So 3/2, replace the x with 9. So 9 plus 3, quantity squared. And I'm just going to work it out. I'm not plugging 9 into all of these because it doesn't work that way. You have one input, you get one output. So you have to make sure you plug it into the corresponding expression. 9 falls under the green umbrella, so it goes into that green expression. Now we just have to do our order of operations. So parentheses first, 9 plus 3 is 12. And then I have to do powers, so I've got to do the 12 squared. That's 144. Let's see, let's make this over 1, see if we can simplify things a little bit. So 2 goes into 144 72 times. So I'm just left with doing 3 times 72. And we have 216. All right, no sweat. Let's do f of 0. So where is 0? Let's see, 0 is right about here. So that means it falls under the blue expression. And that's the only guy I'm going to plug him into. Now this is kind of a weird one, because this blue expression is 45. So we would say this is equal to 45, and any place I see x, I'm going to replace it with my input value of 0. But you see there is no x. It's just 45. So there's nothing more for me to do here. The answer is 45. Okay, that's it. And you might say, don't we need to do 45 times 0? Well, that's not what this says. This says that any value that fits into this expression right here, or this inequality, any value of x between -9 and 4, it's going to give you 45. It's not 45x, it's just 45. So in this little region right here, in between -9 and 4, your function is just this horizontal line at 45. Okay? So every output in that region is just going to give you 45. And finally, if I ask you to do f of 5, well, where does 5 fall? 5 is right here. And you see that 5 doesn't fit into the pink region, or the blue region, or the green region. 5 is in no man's land. So if 5 is trying to fit in, he's going to be out of luck, because there's not an expression that is willing to take on an input value of 5. So this function, when you try to evaluate it at 5, it doesn't work. It doesn't have a place for it to go. So this is going to be undefined. So if we try to plug in anything between 4 and 6, not including 4 and 6, but everything in between, your function's undefined for that. So if you were to look at a graph of this, you have a line right here, you've got a horizontal constant function right there, and you've got a parabola. But in between these guys, there's going to be a gap where your function just doesn't even exist, because it's not defined for that. So any input value in between 4 and 6 is going to give you something that's undefined.